All right, welcome to your last lesson in in circuit 3. We're going to be interpreting functions. So we're going to construct a graph to model a relationship between two quantities, and we're going to be able to describe a functional relationship between two quantities by analyzing a graph. So we're actually going to skip the building background because we did the concept, which was the previous page. That was kind of the building background. Okay. So here we go with our first one. It says the graph shows the distance of a car as a function of time. What that means is that we're looking at a car and we have the time and we have the distance. So make sure that you see that. We have the time and then we also have distance. So how far they are driving. Describe what someone who observes the car movement would see. Okay, so if the distance is starting at 0 when it increases, that means that over time they're going further. They're starting to drive. They're going further away from wherever that distance is from. Okay, the flat line would mean that they're staying where they are. And then a decreasing line would mean that they're coming back closer because their distance is starting to decrease. So then they're coming closer. Okay, so if I start here, they're starting at the point, no time has passed. So at the beginning, or at the start, the car drives away. Then, okay, and that was this part here because it was increasing. So now we're going to be staying the same. It stays the same, so that distance doesn't change. So then, it doesn't move. Okay, it goes a little bit further away, and then it comes all the way back. Alright, so you'd see that car return, and then the car would stay back, because now we're at this point here, right here, the car is going to stay back for a period of time, and it's going to drive away, stay at that point, and come back. So it stays for a short period. Drives away. Stops. And comes back. Okay, sorry, I kind of went over there. That's supposed to be for that first one. That was a really bad line. I don't know why I did that. Okay, number 2. This one says the graph shows the speed of a car as a function of time. So this time we're looking at speed. So that's really important that we see that we see the speed and we see the time. Okay, so we need to describe what this would see. So a speed, as time goes on, if the speed is getting faster and faster, that means that they are increasing their speed. They're kind of stepping on that gas. They're going faster. Okay, if it has a flat line, that means that they're staying the same speed. And the decreasing line with speed, that means that they're slowing down. So if you're going to see what someone would see here, maybe type it because my handwriting isn't very good. Okay. So if we start here, that would be that the car starts to increase in speed. Whoops. Okay, then, why does that keep happening? Then right here, it stays the same. So then it stays the same speed. Okay, and then it quickly speeds up, and then it's going to slow all the way down to a stop because it went all the way down to the bottom. So then it speeds up, and then slows down to a stop. When it's down here, this is stopped for quite some, what is happening? This is stopped for quite a bit of time. So it stays stopped for a little while, then speeds up, and then right here it stays that same. So it's going to speed up. The car starts driving, it's speeding up, it's going faster, faster, faster. They stay at that certain speed. So this would be like 55 miles per hour. They're just going to stay there. Okay, so then stays at the same speed. Then finally it slows down. Okay, so slows down, decreases in speed. All right, so go ahead and write that. If you need more time, make sure you pause the video because that was kind of a lot to write. Okay, next page. All right, so it says Nina rides home from her bike. Rides her bike home from her home to the school, passing by the library on the way, and traveling at a constant speed for the entire trip. We're going to sketch a graph of Nina's distance from school as a function of time. So that means our input is time. So when we create this graph, our x-axis will be time, and our y-axis will be distance from, what did we say, distance from school. Okay, so this is time, and our y-axis would be distance. So what happens over time? Well, if I'm thinking about school, she starts really far away from school because she's starting at home. So she's far away to begin. So she's far away to start because she's all the way at home. And then as time goes on, she gets closer. She gets towards the library, and then from the library, she gets towards the school. So then as time goes on, she gets closer. Okay, so if I drew a line, she's going to start really far away. So the distance is going to be really high. And then as time goes on, she gets closer and closer and closer and closer until finally she's at the school. And that's when she would stop. So this would be when she starts at home. The library would be about here probably. And then finally she's at school. So she's getting closer and closer to the school. The distance from school decreases. Okay, now this one looks almost the same, but we have to read the directions a little differently. It says, Nina rides her bike from her home to school, passing by the library on the way, and traveling at a constant speed for the entire trip. Sketch a graph of Nina's distance from the library as a function of time. So again, this is going to be time, because it says function of time. And our y-axis is going to be distance from the library. Okay, so this is our distance here. Okay, so what happens over time? Well, when she starts at home, home to the library would be decreasing. So she starts away, and then they would be at the library. So that would be at the 0, so at the line. So if I start here, and it's not that far away from the home and library. So here's home, and then down here, this would be where the library is. So she goes from home to library. So at the point that she's at the library, there's no distance because she's there. Then she goes to school, and school is 600 meters away, so it's going to increase as she goes to school. She gets further and further and further away from the library. And it's even going to go past that home because it's 600 meters away, not just 200. It's going to keep going and going and going and going. So that would be about school there, okay? So from the library to school, our distance increases. My handwriting is really bad today, so make sure you're listening. All right, how do we determine a story from a graph? We need to understand how the variables, or the two different parts, impact each other. All right, and that is it.